So good day everyone, we are the group 5 and we are going to discuss about the following topics. My name is Christine Joyce Orfresio and today I will be presenting a report on air movement. The report will cover the types of air movement such as convection and advection, the factors affect air movement and how it impacts weather patterns and climate. I will also be discussing about the tools and technologies used to measure and predict air movement, such as weather balloons, weather radars, and satellites. By the end of the report, you will have a better understanding of how air movement works and its impact on our environment. So first, what is air movement? The term air movement refers to how air moves into the atmosphere, and it includes a variety of phenomena such as large-scale circulation patterns and small-scale currents. A number of things such as temperature differences, air pressure variations, and the presence of land and water masses can affect air movement. We have types of air movement, which is convection and advection. But moreover, we have another type of air movement, which is yung wind. Wind is caused by the movement of air from areas of high pressure to areas of low pressure. And it is perhaps the most well-known type of air movement that can be felt on the ground. So we have here convection. Convection is caused by temperature differences and can take place on both small and big scales, ranging from the leisurely ascent of warm air over a sunlit field to the strong updrafts of a thunderstorm. Next, we have advection. This can happen due to a variety of factors such as differences in air pressure or the presence of fronts. Advection can also be caused by winds, which are caused by the movement of air from areas of high pressure to areas of low pressure. Since all of the types of air movement contribute to the transportation of heat and moisture around the planet Earth, and can affect the development of clouds and storms, they can all have a significant impact on weather and climate. Therefore, forecasting the weather, researching climate patterns, and managing air quality all depend on an understanding of a various types of air movement. The temperature and pressure variations are the two main parameters that have the greatest impact on air or wind movement. So we have temperature variation, which is the solar radiation hits the surface, causing it to travel vertically and create convection. Whereas air that moves parallel to the Earth's surface is referred to as an advection current. These movements are caused by temperature variations at different layers of the atmosphere. And next, we have the pressure variation. Due to the rotation of the Earth, air moves in a spiraling pattern across pressure gradients from areas of high pressure to areas of low pressure. For example, air movement around a low pressure center is referred to as a depression, while that around a high pressure center is referred to as an anticyclone. So, air is all around us, even when we aren't aware of it. When you feel air movement, however, it might be a sign that the weather is changing or that one is approaching. The way the air moves affects the weather because winds transport conditions from one geographical zone to another. By passing through each other and moving in a particular direction, this also affects the type of weather the region will experience on a daily basis. So the following slide will examine some of the most popular instruments and technology for measuring and forecasting air movement, including weather balloons, weather radars, and satellites. So we have weather balloons. Weather forecasting is made more accurate by using the information collected by weather balloons, which also helps to better understand the composition and movement of the atmosphere. So we have weather radars. Weather radars employ radio waves to detect precipitation, which are then reflected, allowing them to determine the location and strength of the precipitation. They can be either ground-based or mounted on airplanes or satellites, providing coverage of broad areas. The information gathered by the radar can be used to create a map of the precipitation, which can be used to forecast the weather and to track storms. Modern weather other systems can also measure other atmospheric parameters such as the wind speed and direction and humidity, providing the meteorologist with detailed information on the atmospheric conditions. So lastly, we have satellites. The two main categories of satellites are those in geostationary orbit and those in polar or low Earth orbit. Satellites are spacecraft that are launched into orbit around the Earth or other celestial bodies. They can be used for a variety of purposes, including communication, navigation, weather forecasting, and scientific research. And here we have anemometer. The most basic sort of anemometer is a cup anemometer. It consists 3 or 4 cups attached on a vertical shaft that is installed on a rotating base. As the wind blows, the cups turn and the number of turns is recorded over time, allowing the wind speed to be estimated. In conclusion, air movement plays a critical role in shaping weather and climate patterns. The movement of air driven by temperature and pressure differences helps to transport heat and moisture around the earth, which can affect the formation of clouds, storms, and precipitation as well as temperatures and humidity levels. The different types of air movement such as convection, advection, and winds are closely linked to weather and can be observed in the atmosphere with the help of tools and equipment. The wind is caused by the movement of air from areas of high pressure to areas of low pressure. Thermals are another type of air movement which occurs when the sun hits the ground, and air currents are large-scale movement of air masses driven by temperature and pressure differences. Understanding the connection between air movement and weather is essential for forecasting weather, studying climate patterns, and managing the impact of air movement on our environment. Additionally, human activities can also affect air movement and weather and climate patterns, thus, it is important to consider their effects as well. So, thank you for listening. I'm going to introduce you the next presenter, Mr. Mendoza.
Good morning, guys. I'm John Benedict A. Olf from Betsipet 2D. How wind is formed. Wind is caused by uneven heating of the Earth's surface by the sun. because the Earth's surface is made up of different types of land and water. The Earth absorbs the sun's heat at different rates. One example of this uneven heating is the daily wind cycle. So during the day, air above land heats up faster than air above water. Warm air above land expands and rises, and heavier, cooler air rushes to takes its place, creating wind. At night, the wind are reversed because air cools rapidly over land than it does over water. In the same way, the atmosphere winds that circle the Earth are created because the land near the Earth's equator is hotter than the land near the North Pole and South Pole. So, para magets natin lalo is may papanood din tayong video.
And I'm going to put it here, and you should be able to see, yeah, I actually have a small current of wind.
So, dahil yung warm air is lighter kesa sa cool airs, kaya siya nag-rise up. Then, yung cool air is sinking, pinapalitan naman siya nung warm air. Pinapalitan niya yung warm air. Kaya yung wind is nagpo-form.
You're going to see, I can't get it to go through the tube because the air is moving through the tube this direction and it's pushing it out. Even if I try shooting it in the tube, I'm going against the wind and it's not working. So remember what's happening.
And also yung pag-spin ng Earth is nakaka-help sa pag-move ng air sa Earth. Ayun lang. Thank you.
Good day everyone, I'm Rostan James H. Mendoza. We will discuss about low pressure. A low pressure system has lower pressure at its center than the areas around it. Winds blow towards the low pressure and the air rises in the atmosphere where they meet. As the air rises, the water vapor within it condenses, forming clouds and often precipitation. Because of Earth's spin and the Coriolis effect, winds of a low-pressure system is veer counterclockwise north of the equator and clockwise south of the equator. This is called cyclonic flow. On weather maps, a low-pressure system is labeled with red L. Yung lower pressure ay may center sa lugar nito at ay nakapaligid dito at ang hihip ng hangin ay papuntang lower pressure habang tumataas ang hangin at ang singaw ng tubig sa loob nito ay namumuo o nagpo-form ng ulap at kadalasan nagkakaroon ng ulan, snow at iba pa na tinatawag nating precipitation. Sa kadahilanan ng ang mundo ay umiikot at nagkaroon ng Coriolis effect, ang Coriolis effect ay nangyayari sapagkat nga ang mundo ay nagro-rotate on its axis at ang umiikot na hangin ay pinaglihis o nagde-deflected toward the right in the northern hemisphere and toward the left in the southern hemisphere. Yung hangin ng low pressure ay umiikot pa counterclockwise sa north ng equator. Ayun nga. At umiikot naman pa clockwise sa south of the equator. This is called cyclonic flow. On weather maps nga. At ang lower pressure system is nakalabel siya with L na red. Ayun lang po. Ito po yung halimbawa ng low pressure. Kung mapapansin niyo po yung cold at warm na hangin ay pupunta or directly towards to low pressure. Then, yung hangin ng dalawang yan ay aakyat at magko-condense po at magpo-form ng tinatawag nating ulap. Then, yung tinatawag at magkakaroon tayo ng tinatawag na precipitation kung saan, ayun nga, yung ulap na yun ay maglalabas ng droplets ng ulan or ng snow. Ito naman po yung Coriolis effect. Ayun nga, kagaya ng sinabi ko, Kaya po tayo nagkakaroon ng Coriolis effect dahil nga to the Earth rotation. Then, ayun nga po, sa kadahilanan ng pag-ikot ng mundo, yung hangin natin ay nagde-deflect to the right in the northern hemisphere at deflected to the left in the southern hemisphere.
Good day everyone, I am Ryan Moreno, and now we're gonna talk about surface winds. First, let us define what winds are. So winds, known as the moving air masses in response to different pressure and temperature gradients in the atmosphere. A key to remember is that when overall energy of the system is lowered, air molecules will move from high pressure to low pressure. Then high pressure pushes air to the low pressure areas. Then the force that pushes air from high pressure to low pressure to make it stay in its equilibrium is known as the pressure gradient force, or PGF. This creates the wind in the atmosphere. Now, Coriolis effect. It is a deflection in the circulating air toward the right in the northern hemisphere and toward the left in the southern hemisphere. Deflection of circulating air happens due to Earth's rotation. Now let's go to surface wind. These are winds that are near the Earth's surface that are normally measured at 10 meters above the surface. It is an effect of friction where they move across isobars. There are two types of surface winds based on the distance over which they occur. So first we have synoptic winds occur due to the pressure differences over thousands of miles. It would blow across the entire country due to the pressure differences. Then second, we have the local winds occur on the scale of 1 to 30 miles, commonly experienced in the beach and ocean. Now to understand how surface wind is formed, we have here terms that are related to it. First, we have isobars. It refers to the line of constant pressure seen on weather charts that show pressure fields. It allows the reader or user to follow areas of equal pressure. Then we have the local maxima and local minima. Local maxima is symbolized by H in red. These are referred to the high pressure system, and local minima is referred to as the low pressure system and symbolized by letter L in blue. As you can see here in the lower right, you can see here the local maxima H and the local minima L. Then Coriolis force and friction together balance results to a wind that crosses the isobar. Moreover, we have friction, which slows down the wind, throwing an impact to the speed. It works against the wind. On the other hand, Coriolis force is trying to turn the wind, meaning it opposes the flow of the wind. It works in the northern hemisphere to the right of the wind. Since the wind is being slowed down by friction, it can turn fully parallel to the isobars. This resulted to winds moving across isobars towards the low pressure. It reduces Coriolis force and PGF becomes more dominant. Then we have friction force and resulting wind. Friction force opposes the direction of the wind but not strong enough to stop the wind. Then resulting wind slows down due to frictional force. It is what we actually feel in that particular area. So that's all for our discussion about surface winds. I hope you learned something. Thank you.
Good day, I'm Wilbert Ogate from Betsabet 2DNS, and I'm going to report about local winds. Now, a local wind system refers to wind patterns that are specific to a certain geographical area or location. as opposed to a larger scale wind system that can affect a region or entire hemisphere. This wind system can be affected by various factors such as topography, land use patterns, and temperature gradients. The example of wind system include sea breezes, valley winds, and mountain winds. These winds are caused by the temperature difference between land and water, valley and hill, etc. These winds are generally weaker and shorter lived than the regional or global wind system that and can vary greatly from day to day or even hour to hour. The next one is a sea breeze. Sea breeze is a cooling wind that is blown from the sea towards the land. It is caused by temperature difference between the land and the sea. The lands heat up more quickly than the sea during the day, causing the air over the land to rise and cool air over the water blow in to replace it. So the cold air here will be thrown to the land, and the heat of the land will cause the air to go up. Then the air on the above is going to blow it down to the sea again, so the cycle will repeat. This cool air is also known as a sea breeze. Sea breeze can help lower temperatures on hot summer days and can also help to reduce humidity in coastal areas. They typically blow during the afternoon and their strength can vary depending on wind patterns in a specific area and the temperature difference between the land and sea.
Good morning, guys. I'm John Benedict A. Alpot from Betsipet 2D, and i-discuss ko ngayon yung land breeze. The wind that blows from land to sea is called the land breeze or the offshore winds. These winds blow during the night. Warm air over the water rises and cool air from the land takes its place. So yung at night, dry land cools faster than water due to the water's large specific heat capacity. Since the land cools faster than the water, the air above the water is now warmer and less dense here than the air above the dry land. Therefore, the path of the convection current is the opposite of the daytime current, like yung sa nireport ni Wilbert. So, warm air above the water is rising, drawing in the cooler air from the land. Yun lang. Thank you.